Okay, moving right along. So if you look at the next page on Canvas is you've got an aerial of the project site. And I also have the same aerial in the drawing that I'm going to give you. So if you need an aerial, you can download it here. It's also the aerial as a PDF if you need it. But the nice thing about the Civil 3D now is that you can actually log on with your email account that you use, and the geolocation pops right up for you. So I'm going to do that instead. All right, I'm going to give you the design project to start with. So it's going to have that aerial in it, and it's going to have some of the drawing already in it. So use this class design blank drawing. All right. So you're going to determine the minimum road right-of-way design, vertical alignment, horizontal alignment. You're going to do cross sections. You're going to make sure that your roadway is perpendicular. The lines that I show you in the drawing, the red lines that pop up, let me go ahead and start downloading this. The red lines that pop up are your connection points. That doesn't mean that you have to extend off of there. I'm just telling you those are the tie-in points at the ends of those lines. And I'll show you that right now. So let me open up Civil 3D while I talk. Okay, it's opening up, so I'm going to go ahead and go on. Make sure the roadway corridor, I know this is hard to see, but you can see it in Canvas. It's just to give you a guide to go along with what the page is. The roadway corridor cannot impact the wetland. That means when you tie back down from your road, the back slope has to tie into natural grade, then it cannot encroach into a wetland buffer of 15 feet. So take the wetland area, offset it 15 feet, and you can't get any closer than that to the wetland. Okay? The proposed layout of the buildings on the development needs to stay, but the parking lots can be modified. You can whack them, you can move them. All right? Plan and profile sheets required to show the horizontal and vertical data, storm data, in addition to typical details. I want to be able to see at least when you start to do, for some of you that have had hydrology and hydraulics, where's the low points going to be, and that's where you're going to put your inlets. So my goal is by the end of the semester you can actually put storm inlets in your plan also, and they show up in plan and profile. That just gets you one step ahead. Sections should be required every 200 feet along the roadway. If you do more than 200 feet, you got a boatload of cross sections, and it's not that big of a deal. So I'm showing you how to use the cross section in Civil 3D. You will be required to create a proposed design system for the roadway, and I will assist you in determining the invert elevations on it, because that's not what you're in this class for. That would be your hydrology and hydraulics class. We would do the whole calculations of inverts. All right? So as this has opened up, it's still thinking on this end, so give me one more second. So I'm going to go next. Now I have a checklist over here on what should be inside of your construction plans. This is your plan and profile sheets, etc. The design speed, which is going to be discussed in the engineering report. Let's say our design speed is going to be 30 miles per hour. And we'll take a look at the county and the DOT codes for 30 miles per hour. Typical sections, you'll have a pavement. It's going to have a width, a cross slope, and basically asphalt thickness, base thickness, and subgrade thickness. Shoulders, you don't need a shoulder technically if you have curb and gutter. Okay? You can still have a shoulder that the government or the DOT says that is going to incorporate your sidewalk and all that. It's basically the rest of your driveway. Do you ever drive down US 192 or any road that doesn't have curb and gutter on it and it's just ditch? They actually have a certain width of shoulder that slopes at a certain angle that can either be paved or unpaved before you hit the ditch. So that's so when you pull over, your car doesn't sink down into sand when you go to try to change your tire from a flat tire. So there's, on this one, we're not going to require a shoulder, but I did want to make you aware that that is something that should be on a set of plans if you don't have curb and gutter. Daylight to existing grade. when I say daylight, in Civil 3D is a when you do the corridor, it asks you, do you want to daylight? Daylight means you're going to taper back down to the actual ground. Let's say your road was 10 feet in the air. You're not going to build, retaining walls 10 foot in the air. So it's a vertical wall up and your road's above it. You all have seen them on the turnpike where they've got the vertical walls going for the ramp going up to the... We're not going to design it that way. So we have to build the dirt back down to the existing ground. That's what daylight means. Building the dirt or building the dirt up to existing ground, depending if it's a cut or a fill scenario. Okay? So the depth for the final grade of the sun, the elevation of the final grade at center line, you've got foreslope and back slope. Okay? Back slope is cutting down to the ground. The curves, we're going to use a type F curve in this class because it's already set up into our templates. But be aware that DOT has a type A curve. They have what they call a drop curve or a Miami curve. You also have sidewalks. We already said it was 5 feet wide. You can have them 4 inches thick. That's just going to be part of the cost estimate if you did a cost estimate. Here's the other thing. Does anybody know what sidewalk slopes maximum can be? The cross slope of a sidewalk can be 2%. Okay, they can't go over 2%. Okay. The other thing is when you're going longitudinally on a sidewalk, you can't go over 2% unless it's at a short distance. And then you have to fit ADA code. It goes up a bit and it has a flat ramp because anybody in a wheelchair has to be able to get to point A to B without having any issue. Is it that I couldn't remember off the. It's a 30. It's how
30 feet and then it has to have a flat spot.
Goes 30 feet and has to have a flat spot, and I think it's no more than 6-inch rise in 30 feet. There's some I don't remember off the top of my head. I have to look that up. All right. So your plans, you have north arrow, scale, street center line, right-of-way lines, stationing, street names, so you can make up whatever street name you want. Your horizontal alignment, it has to have the curve data in it. Intersections, you will have 2 roads intersecting, so the curve returns at the intersections need to be 40 and 50, 40 for ingress, 50 for egress, I believe. You have traffic signs. A set of construction plans or a set of roadway plans, you can't not put a stop sign and stop bars and crosswalks and this is a one-way and this is a dead end and this is a cut-through. You have to put some type of signage in there. Okay? Now, note that signs are to be furnished and installed by the construction agent. So sometimes on plans, you'll denote that depending on who's responsible for it. I pulled this list off of one of the county requirements. So in profiles, the stationing, the scale, surface, the existing ground is going to be a dashed line. The proposed ground is going to be a solid line. You have vertical alignments. You'll have center line of the roadway. Every stationing should, at the bottom of your band, should be every 50 feet. It should have an existing grade and a proposed grade. Now, the more information that your plan that has on your plan, it's easier for the contractor to build. If you don't put enough information, he's going to be calling you up to get clarification, just to let you know. On the drainage plan, you have pipe size, diameter, the type. You can see the inverts in the plan and profiles, the inlets, the cleanouts, the maximum cover, minimum cover, the alignments, type of manhole inlets. And then down here below, the minimum requirement is going to go through there. I'm not going to read through all of these. Take a look at them. If you have any questions, this is what I'm going to be looking for on your plans. If it's not there, then you're going to be deducted points unless it's not unless it's something above the requirements. Here's a PDF or a document of that. Now, just as a clarification, I've been adjusting some of the stuff that's on Canvas, and these documents are a little bit older. So go by what's listed in Canvas, as in what you can see right here, and just make note that it's not a huge difference, but every once in a while I'm changing some of the word for clarification. Question?
No,
Oh, just checking. Okay. All right. Final project design report. This is what you're going to be revising. So I've given it to you in a document. So let me get that. Open. I'm also over here on the other side is I'm looking for give me 1 second. I'm opening up the plan that I showed you all. Oh, just FYI, when the drawing pops up, it's going to say, I want to bring it over to the other side so you can actually see it when it pops up. Give me 1 second. So I'm going to go, here's the drawing. It's going to say this drawing was saved in an earlier version. That's fine. Just go ahead and close out of it and ignore the unresolved references. I'm going to close the task pane. I don't use the task pane, and we've got the prospect of the settings, etc. So what I'm giving you is this set of plans. What I mean by the tie-in point, this down here, this grip is your tie-in point. You don't have to follow the link, the line right here. You can, as long as it's perpendicular, when you bring it in, shift perpendicular. Make sure that it's perpendicular to this yellow line. Okay? So if I drew a line out here and I go perpendicular to that yellow line, notice that if I zoom in tight, there's a gap there. Just make sure that when you start to draw, you're going to be perpendicular to this yellow line. I know that's a little OCD, but I just want to make sure that you recognize that. I hate things being a little bit off. Anyway, so this is the wetland. So you could take this wetland. Do you want me to change that to a white color? Would that be easier to see? Give me 2 seconds. Is that easier to see for you all? Okay. So take the wetland, offset it 15 feet automatically. You can't touch the corridor on any closer than that. Same thing with down here, which you don't have to. My original thought was you're going to build 2 roads, but for right now, the first road is going to come in here. If you have enough time, you can build a second road that comes through here. But you do have to do the one that bounds the outside. Okay? You can adjust. You can move these parking lots wherever you wish, just not inside this wetland, but however you wish. Now, this is the AutoCAD, the Civil 3D program. This is your base file to start with, however you want to design off of it. And you know how I've been giving you the step-by-step tutorials and I automatically give you this line to draw by? The reason I do that is because that was where you're going to stick your profile. And if you take a look at the PP1, PP2, PP3, plan and profile, plan at the top, profile at the bottom, I got them kind of set up so it should fall in place for you so you're not having to worry about viewports as much. I'm trying to be helpful to you in that. So when you use this template, you have the views already set up. Of course, there's nothing here. See that dark line right there? That's the line over here. So if you start anywhere else, guess what? You're going to have to be manipulating that bottom viewport. Just FYI. I don't have a problem with you doing that. I'm just saying that's how it's set up. Also over here is where I've kind of said try to put some of your cross sections. Just hint, hint, wink, wink, nudge, nudge. They should pop up into this section here. All right. What I'll also ask, I don't have it here, I don't believe, is I'm going to probably ask you to create another page, and it's going to have your overall geometry plan. So it's going to have the entire site, and it's going to have your layout of your roadway in there. Typically, you start with the geometry plan, and then you do plan and profiles in your construction plans. Now, DOT, I've always done plan and profiles in subdivisions, okay? So the plan's on top, the profile's on the bottom. Sometimes you actually see DOT have plan in one sheet, and then the next bunch of sheets are profile. They don't actually put them. I like them married up on the same sheet because you can see top to bottom. If not, then I'm having to look at two sheets more often than not. But it does happen, so don't be surprised when you get into a job that there's two different sheets. Be like, that's not what we did. Yeah, everybody has a different thing. All right, so things that you need to change. This will be your final report. It's not November of 2015 anymore. It's a few years ago. Are we in Osceola County? No, our project's in Polk. So you can start changing these squiggle lines, I can't do anything about those. That just means the computer did not like that as a real word. So it's just the words that it doesn't like. And to me, stormwater is one word. The computer still doesn't like that. All right. So go through here and you'll see what's in red that needs to be changed. Okay? Is this going to be functioning as a collector street? No, it's going to be a local road. And then you can start going through this to find out the information and where to find it. Okay, on this one I'm going to take, just to clarify, so since you're all sitting here, unless somebody doesn't actually watch the video, I'm going to tell you to take these PPMs out. That's Plans and Preparation Manual, and I don't have a copy of that to give you this semester. You can look it up online. If you want, it's called the Plans and Preparation Manual. That's where you would find this information. The other information is from the DOT book. So I'm going, all right, the design value isn't 10. We're going to use 30. It's going to be a urban local road, and you can look at the LDC table for the widths, the design vehicle, the curves. We're going to take a look. We said 300. So go through those. Main access, these are the things that you're going to have to update. Read through it. If you have an issue, just let me know. These are the design calculations. This, which is really nice, actually came out of the Civil 3D program. I didn't write any of that up. I told the computer to use the toolbox, and it created all the design information up for us, which is really, really nice. And then I did do the calculations on my own. Simple enough. You've already got the information set up, so it's no problem. Same here. Here's the curves for the defining elements. Your chord, your chord, your deflection angle, and the deflection increment. Again, Civil 3D puts all of this information together for you. And I did do one. You only have to do one curve and one horizontal curve and one vertical curve by hand. Everything else can be with Civil 3D. Because I want you to know how to do both. Here's the other reason I want. How many of y'all have you ever used a computer program or a calculator and you thought you did it right, and it gives you an answer, but the answer is not actually what you thought it was going to be? Yeah, because you can't always trust the calculator to do exactly what you think that it's doing, because it might not be doing what you're thinking that it's doing. So it's always nice to have a second check that you know what the system is actually trying to perform, the calculations it's performing. So here's the design speeds. So if we have a local road with urban or rural, so we're looking at no restrictions, a design speed of 30. So this is from the DOT Green Book. We have and the reason I tell you about the vehicle specifically is there's a program in Civil 3D, and it used to be an off program, like you do it on your own. It was called Auto Track, and you would actually put a vehicle in and go around the roadway path to make sure that the car would fit. So I want to make you aware that there is a name. So this is a double bottom semi-trailer combination, interstate semi-trailer, interstate semi-trailer. So you can pick one of those as the vehicle that you're designing for. Horizontal curve, if we said it is, okay, I said 225, but take a look at this. It is, can you all actually see that out there? I need to make a change. At 30 miles per hour is the design speed. The maximum degree of curvature, 24 degrees, 45 minutes. Note that the minimum radius is 230 feet in a rural area and 285 feet in an urban area, with a super elevated of 0.5%. Okay, so 220 degrees. So 285 is actually the minimum that you can use on that horizontal curve. Now, if I told you that you could use 25 miles per hour, look at the curve that you can put in there. Look at the difference. Now, here's the thing that you have to think design-wise. Do I post 20 miles per hour and design 25, or do I post 25 and design 30? Usually there's a 5 to 10 foot difference between the design speed and the posted speed, just to cover just in case that, okay, I want them to do this, but a safety factor would be 5 miles per hour. Okay? So as a class, let's get as a group. Who wants to design at 30 and who wants to design at 25? If I do a really big one, the curves won't fit into this plan, just letting you know. Raise a hand. Design at 25. 1, 2, 3, 4, 5. I got a half and half. Who wants to design at 30? 1, 2, 3. Okay, here's the thing. You all design at 30, you all design at 25. Put it in your report though, because here's the big scheme of things. That's what design's all about. It's what you want to do. And I don't want everybody to have the exact same design, so I am happy that you have different ones. Anybody that wants to design greater than that is more than welcome. They just have to let me know what their design parameters are. And that's what the report does for me. It tells me what you're all designing on. Okay? All right. Here's something else I want you to be aware of. When we're designing and we've got roads, how many people have seen a sidewalk right up against the curb? There's no little grass area. How fast are those cars going in that area next to that road? Pretty fast. Sometimes it's pretty flippin' fast. But here's the thing, is there's got to be typically 4 feet, depending on the speed of the road, but minimum 4 feet clearance between the edge of the road and a pedestrian. So you know what they do is they go ahead and put the sidewalk up tight, but they make the sidewalk wider. So it gets the people further away from traffic. The other thing is those poles, power poles, light poles, whatever poles, are actually supposed to be at least 4 feet away. So if they come careening off the road, they're not smacking into it. So there's a thing called a clearance zone that you're not supposed to build things in. Okay, now, so we're looking at 30 and 25, flat terrain, rolling terrain. Here in Florida, we are pretty flat. If you're in Claremont, you're pretty rolling, okay? So our terrain's different. We're looking at a local, and this is the maximum design grades in percent. In the local, we have 7 and 7. So that means 7%. I have never seen in my designs anything more than probably 2%. Because we're so flat here, well, in Osceola County. But 7% is pretty substantial in this area of Florida. But that would mean, here's another thing. Oh, let me get this up. Okay. We're going to bring in a little bit of hydrology and hydraulics right now. You have a road coming in here and a road tying in here, right? That's what our plan is. At this point right here, if I put a high point here and sent the road downhill and downhill, that would not be good because of the drainage. This pipe system here wouldn't have enough capacity to take all the water from the road. So what you can do is you would put, this is a high point, make it go downhill and come back uphill and put a low point here, come downhill, low point here, come back up. Does that make sense? Yeah, because we can't put DOT, because this is a DOT road, DOT will not let us put extra water on their roadway because the pipes don't have capacity, the storm pipes don't have capacity. So you have to, from this black line right here, which is our right-of-way line for this road, and this black line, this road, water has to come back to us and not to the street. They've accounted, the storm pipes in this section of the road should have accounted for the sizing there. Right? So that first, instantaneously, as soon as you get to this point here, you need to start sloping downhill. All right? Now, you ask yourself, how do I find out what that station is and location? You create your alignment, make sure your alignment starts right at that point right here. Sometimes we have them start at the intersection just for tie-in's sake, but make your life a little bit easier. Tie in at this point right here. Find out what that elevation is, and I can do that by hovering really close to it. Its existing elevation is approximately 123.92, so everything opposite has to start going downhill. And these are just little things that you're thinking in your critical design. All right. So we've talked about the design report. Oh, let me go back to the Word document. Okay. All right. Here is what I was telling you about the change, maximum change in percent grade. That's that A. Percent coming up, percent going down. At 30 miles per hour, that A can equal 1. If it's above 1, it has to have a vertical curve. This is the good thing about slowing the speed down. You have 1.1. So you can actually have a greater A. The slower it is, you have a greater change. Because we all know, and we've all been behind those people that have the low-riding cars that go really slow over a speed hump. And you're like, I want to go. You know, it's because the slower they go, the less they have a chance of bottoming out. So if you're flying, let's say you posted anything over the 0.6, that means, just think of it, 0.3% coming in, 0.3% coming out. Here's, take this note right now. I don't know if I have it written down, but make sure you get this down. Roadways cannot have a minimum no less than 0.24 in Osceola County. 0.24%. That's the last time I looked. I always design my roads at least at a 0.35%. I've done 0.33 and 0.3. But have you ever thought about what 0.3% looks like? That means in 100 feet, you're only going 0.3 feet. 4 inches maybe? Is that what 0.3 is from feet to inches? About 4 inches in 100 feet. Granted, that makes water get off the road. That's the whole reason of it, is it gets the water off the road. But that's not a whole lot of change, right? And the other reason why they don't change like 0.5% up this is because that causes you to do a lot of when you're driving. It is what it is. But just be aware of the vertical curve change. Okay. Stopping distances. So we haven't gone over the calculations for stopping distances. So just be aware that our stopping distance for our minimum stopping sight distance is 200 and 155 for y'all that are doing the 25 and the 30. Here's our K values. All right. So if we have a algebraic difference, depending what our algebraic difference is, multiplied by a K value, will give, underneath whatever design speed, will give us our length of required. Okay? So typically, and here's the other thing, typically, and I'm not saying it always has to be, but typically your length of curve is about 100 feet. Because the longer the curve, the vertical curve, the smoother it's going to be. It's a nicer smooth. You don't want a Disney park or a Universal ride where it goes whoop, whoop. Nope, we don't want that. We want a nice elongated, smooth ride. All right. Now notice that the minimum lengths of vertical curves for the major highways. They say, I'm not even going to let you try to figure that out. Vertical curve for 50 miles per hour at a sag is 200, and for a crest is 300. So think about all the roads on the Turnpike, I-4, all your major DOT roads, US 1, interstate, SR, State Road 500, which is our US 192. Those have curves of 300 and 200. Here's another one. We haven't gone over the sight distances yet. So the minimum passing sight distance. So we've all passed people, hopefully not on double yellow lines because that's illegal. So also when you're designing, you have to figure out the lines. Is there going to be on the edge of your roads, white thermal stripe? On the center line of the road, there's a yellow thermal stripe. Is it going to be a passing, no passing? Those types of things have to be thought of also. So we haven't gone over passing distances yet, but we'll talk about that later. Lane widths, local roads 10 feet. I think it says we can, but I think that's a bad idea. What do y'all think the road width should be? I think it should be 12. I think it should be 12. Okay. You've also got the 2-lane rural, shoulders with rural. We're in a rural area, urban. Design speeds, that's based on width. So we'll go ahead and keep scrolling down. Here's your clear zone. In an urban area, you have a clear zone of 1.5. That's for 25 miles per hour below. We have 4. 4 is your minimum. And notice that where it says it's taken off of. More sight distance. And all of these figures came out of the DOT Green Book Index. Okay? This goes back to stopping lengths and all that we haven't covered yet. These are more of numbers that you have to pull to confirm that you're meeting. When we're talking about clear sight of distance, we've all pulled up to an intersection and the white bar, the stop bar is like way back here. There's actually a minimum distance from the drive lane that you have to pull back. Okay? Now, sometimes we're pulled back so far that the crosswalk, we can't see. We're not supposed to drive in the crosswalk until we're allowed to. But if we can't see, we keep edging up. There's supposed to be a sight triangle. So this person driving here can actually see if any cars are coming. But that doesn't always happen because people put shrubs and plantings and monument signs and all that in that way. Just be aware of there's a lot of landscapers have to prove this so they're not impeding the view, the clear sight triangle. Okay? So I've listed some of the information on the details and where I pulled them from. Now, just as a remark, I actually used in this, these details here, in this that I'm showing you now, is actually from Polk County, Oregon. When I pulled and wrote Polk County, it popped these up and I was like, fantastic. But I didn't realize it was Polk County, Oregon until I looked at the detail sheet. But I tell you what, they have the best written land development code standards, easy to read. I said, you know what? We're going to pretend they're ours. Because let me show you how to go to Polk counties. And theirs aren't bad, don't get me wrong. If you go, and this is how I do it. I type in Polk County, this time Florida, and I go Land Development Code. Here's the website it'll automatically take you to. We need to look at Chapter 8 subdivisions. I'm going to go ahead and download this. I've downloaded these already to your all's Canvas, and I go save. Now the reason I don't want to look at it through here is because when I open it, I can actually have tabs. If you open it online, you don't get these bookmark tabs. So you're actually looking at section 821 access. You're looking at the minimum right-of-way. So this should look familiar, minimum clear zone. Everybody borrows from everybody, but that's from the DOT. And they say within the standard, in this Chapter 8, they say follow the DOT code unless ours are more strict. So you would have to go through all of this and figure out, okay, whose is more strict? Mine, Polk County, Osceola County, whatever county you're in, compared to DOT. Now I want to show you where the DOT index is. They've also been updating them. So if I go FDOT Green Book, again, it's not actually green. This is the website that'll pop up, and you can go, it is currently being revised, just FYI, it is currently being revised, but we use the one that we had most on hand. And again, once it pops up, I'll download it, and I'm going to save, because if I open it up off of the desktop, it'll allow me to have my bookmarks. And we're going to be looking at Chapter 3. So if you scroll through Chapter 3, you can see a lot of the same tables that I showed you. Okay. So that's where I'm getting the information. So be aware of where the data is coming from that are design parameters. But I liked Polk County, Oregon's better, just because it was literally laid out really, really nice. Oops, wrong one. All right. Now, here is the comment letter that you need to address. I pulled this. I just took the pretty, how they did it a few years back, and I just wrote up what the comments were. You can go through these. Comment 1, identify roadway classification as industrial, commercial, and revised design to meet the urban geometric design standards. For example, make horizontal curves 500 feet is the next comment. Do I have to? Based on my design speed, do I have to? No, because if I'm doing 25, then I can go all the way down to 160, but if I'm doing 30, then I'm going to do 285. So you'll go through this. You'll go through the comments. The letter is here so you can address the comments. Next. This is why you have the rest of the semester to work on this. This is a big project. Okay? Now, I've attached the design standards. I'm going to open up this one. This top one right here is the Polk County, Oregon. It never once said that it was in Oregon. And the only reason that I realized it, down here, if you look at the address, it's in Dallas, Oregon. I said, well, Snapples. But they use the same type of tables. So I just kind of organized this so you could see the difference between design standards. Go next. Here's the DOT Green Book. That's the link that I just showed you. This is the upcoming changes they propose to make. But this is the book that you'll actually use. There's videos on Wolfpack that I show you. Once you get your design, I show you how to get that data to put into your report, both for the vertical and the horizontal. Now, here is the good and the bad drafting standards. I'm going to pause here because I've talked a really, really long time, so I don't know how long this video is.